Next, which nucleophile is better nucleophile? Charged nucleophile is better nucleophile than its neutral species. This is the ammonia. Its charged species is amide ion. Water, hydroxyl ion. Acetic acid, acetate ion. Why charged nucleophiles are better than its neutral species means because of its charge, it can quickly lose its electron pair to acquire the stability and they make bond easily. So therefore, charged nucleophiles are better nucleophile than its neutral species. Next, there are 4 simple steps to identify the given leaving group is better or not. Step number 1. First, we should identify the leaving group. For suppose, when we are taking that what an alkyl halide, this is the leaving group. Chlorine, fluorine, bromine, NH2, OH, whatever it is. This is called as what? Leaving group. Identification of a leaving group. Better is the leaving group, more is the nucleophilic substitution. So now if it is leaved faster, then substitution is happened. So therefore this is. Next, which is the better leaving group? Stronger is the acid, weaker is the base, better the leaving group. Then more is the nucleophilic substitution reaction. Weaker is the acid, stronger is the base, bad leaving group, less nucleophilic substitution reaction. Next, stability of conjugate base is more is the stability of conjugate base, more is the nucleophilic substitution reaction. Conjugate base is stabilized by electron donating group or resonance. If more is the stability, better is the leaving group, more is the nucleophilic substitution reaction. So stability of conjugate base directly proportional to electron withdrawing group and directly proportional to resonance and inversely proportional to electron donating group. Okay, these are the simple steps. Now for suppose why weaker base is the better leaving group means weaker is the base. This is the for suppose weaker, it can't make strong bond with what? Carbon. No strong bond between carbon and halogen. If it is weaker, then easily eliminate, then substitution is faster. For suppose if it is a stronger one, bond is formed between them is very strong bond, so cannot leave faster, so less nucleophilic substitution. Yes sir, if it is not leaving, substitution won't be happen. So therefore less nucleophilic substitution. These are the 4 simple steps to solve that what? Leaving group questions. See now this is called as a what? I am taken that what? HCl. HCl is the strong acid in aqueous medium because it releases H plus ions. Then it will gives that what? Cl minus. This Cl minus strong acid always gives weaker conjugate base. It is its conjugate base, that is a weaker. Next, alcohol is the weaker acid because of plus I group. Alcohols are weaker acids because of plus I group. So therefore this is the weak acid. So therefore its conjugate base is what? Stronger. Stronger the conjugate base. Stronger the conjugate base, bad the leaving group, less nucleophilic substitution reaction. So that is. Now here see now I am given some compounds. Water is given, alcohol is given, another alcohol which is having more plus I effect, another alcohol is given, tertiary alcohol which is having more plus I effect. This side to this side, plus I effect is increases, acidic strength decreases. As we know that acidic strength is directly proportional to electron withdrawing group and inversely proportional to an electron donating groups. So plus I effect increases, so therefore electron donating increases, so acidity is decreases, acidic nature decreases. That means this is the weaker acid, this is the strong acid. Strong acid is having that what? Weaker base. Strong acid is having weaker base, weaker is the base, better the leaving group. So therefore which is the better leaving group? Strong acid. Strong acid is having weaker base. So weaker is the base, better is the leaving group. So therefore this is the better than this one, this is better than this one, this is better than this one. This is the step number 1. Next, step number 2, solve this question which is having a best leaving group. So now this is a phenoxide ion, this is what? Acetic acid, which is a strong acid. Phenol, when we are taking that what? Phenol, for suppose now I am taking the phenol. Now this is a phenol. Now this is called as what? An acetic acid. Now this is weak acid. Now this is strong acid. Strong is the acid, weaker is the base. Weaker is the base, better leaving group, more is the nucleophilic substitution reaction. Okay, this is strong acid is having weaker base. That too, this after releasing H plus ions, this conjugate base is stabilized by that what? Symmetrical resonance. More is the stability of conjugate base, more is the nucleophilic substitution reaction. So therefore this is better. Next, CF3SO3H, CF3COOH and CH3COOH, acetic acid we are taken. Now which one is the better leaving group? See now this stability of conjugate base is directly proportional to withdrawing group. Stability of the conjugate base is directly proportional to an electron withdrawing group. So this is. Now here write its conjugate base. CF3 SO3H. Right, this is an acid. Write its conjugate base. CF3. After releasing H plus ion, it is going to be formed as SO3 minus. Next, write its conjugate base. Write its conjugate base. CF3 COOH. Write its conjugate base. CF3 COO minus. Next, CH3 COOH. Next, write its conjugate base. After releasing H plus ion, they are forming as what? Conjugate bases. These are the conjugate bases of these acids. Now here. Now this is what? An electron withdrawing group. Now this is also an electron withdrawing group. CF3. Fluorine is a minus I effect. No? Now CH3 is what? A plus I effect. So more electron withdrawing groups are stabilized by that what? A conjugate base. Electron withdrawing groups are stabilizing the conjugate base. So here this is plus I effect. So therefore this is less stabilized. Next, among these two, which is more stabilized. Already we discussed in the previous video, SO3 will give 3 resonating structures. This will give 2 resonating structures. More is the resonating structures. More is the resonating structures. More is the stability of conjugate base. More is the nucleophilic substitution reaction. Better leaving group, more nucleophilic substitution reaction. So therefore here conjugate base is more stabilized than this. So therefore this is the better leaving group than this. This is better leaving group than this. Next, here same sulfate ion is there, sulfate ion is there, sulfate ion is there. Next, here what is there? Electron withdrawing group is there. Next, here electron donating group is there, plus M effect. Electron donating group is there. Electron withdrawing groups are more stabilizing that what? And conjugate base. This is the conjugate base. Electron withdrawing groups are stabilizing the conjugate base. So therefore more is the stability of conjugate base, better the leaving group. Better is the leaving group, more nucleophilic substitution reaction. Next, HI, HBr, HCl, HF, which is the strong acid. This is the strong acid. Now strong acid is having that what? Weaker base. Now this is what? Weak acid, very weak acid. This is the weak acid. Weak acid is having that what? Stronger base. Stronger is the base, bad leaving group. Stronger the base, bad leaving group, less nucleophilic substitution. So strong acid is having that what? And weaker base. Weaker is the base, better the leaving group, better is the nucleophilic substitution reaction. So I minus is the better leaving group. I minus is the better leaving group, then Br minus, then Cl minus, then F minus. Next, NH2OH minus, which is the better leaving group. Now NH2 is given. Now NH3 H2. Now what is its conjugate base after releasing H plus ion? This is NH2 minus. After releasing H plus ion, this is forming as a what? OH minus. Now among these two, which one is the strong acid? H2O is the strong acid because hydrogen is connected with highly electronegative element, so therefore it is a strong acid. Here hydrogen is connected with nitrogen. Nitrogen is the least electronegative compared to oxygen, so therefore it is a weak acid. Now weak acid is having that what? Strong base. Next, strong acid is having that what? Weaker base. Weaker is the base, better the leaving group, more is the nucleophilic substitution reaction. Next, in this case, now here I given one reaction, CH3I reacting with the nucleophile, CH3Cl reacting with OH minus. They will substitution. I minus is substituted by OH minus, Cl minus is substituted by OH minus. So nucleophilic substitution is happened. Now which is the faster reaction? First reaction faster or second reaction is faster? Both reactions are nucleophilic. I minus replaced by OH minus, Cl minus is replaced by OH minus. Nucleophilic substitution. Which is the faster? Which is the best leaving group? Already we discussed. Iodine is the better leaving group than that what? Cl minus. More is the better leaving group, more is the nucleophilic substitution reaction. So therefore one is faster than that what? Second one. Next, which is the better leaving group? Here see now, this is given, this compound is given, this compound is given. Here all groups are same, SO3 minus, SO3 minus, SO3 minus, benzene ring common. Next here Cl is there, here CH3 is there. See now this group name is also called as what? And tosyl group. Now this is called as what? Tosyl group. Its symbol is TSO minus. Now here electron withdrawing group is present. Yes or no? Chlorine is a minus I effect. No. Next CH3 will shows that what? And plus I effect. No. Electron donating groups are destabilizing that what? Conjugate base. Electron withdrawing groups are stabilizing the conjugate base. More is the stability of conjugate base. More is the stability of conjugate base. More is the stability of conjugate base, better the leaving group, more is the nucleophilic substitution. So therefore it is better nucleophile than this. Which is better nucleophile than this? Because of an electron donating group. Okay, now these are the simple steps to solve that what questions based on that what? Leaving group ability. This is also called as what? And fugacity. It is called as a what? And fugacity. Okay, step number 1, identification of leaving group. Next, that is a weaker base, a strong base. We have to see that. Next, step number 3, the base is having withdrawing groups or donating groups. So withdrawing groups means more is the stability of conjugate base, better the leaving group. More is the nucleophilic substitution reaction. Okay, no? This is. Thank you.